Hello and welcome to this episode of Physical Attraction, where we're continuing our series on so-called negative emissions technologies. In the last episode, we talked about the idea of tree planting and large-scale afforestation as a way of helping to achieve negative CO2 emissions, drawing down CO2 from the atmosphere to reverse or at least help to mitigate climate change. However, if you did listen to that episode, you will have heard me often interchangeably use the rather jargony term nature-based solutions in place of or alongside afforestation sometimes. So in this episode I want to explain what these so-called nature-based solutions actually are. In some ways it's unfortunate and a bit ironic that I did use those terms interchangeably, since the whole point of talking about nature-based solutions is to emphasise that it's supposed to be about much more than just planting massive new forests. The idea is to work with and to restore natural ecosystems that we've destroyed over the decades and the centuries, and that by doing so you'll not only lock in more carbon but get a lot more extra benefits as well. This is clearly a less industrialised, more holistic and more complex approach than just saying, let's plant 1 trillion trees, as many trees as possible. But its proponents argue that working with and attempting to restore existing natural ecosystems which do sequester carbon is far more likely to be successful and to have obvious co-benefits for people, ecosystems and the natural world than an approach where we just treat trees like nature's natural carbon capture machines and plant massive monoculture forests anywhere we can get our hands on. So the formal definition of what makes something a nature-based solution is this. They are solutions which are, quote, inspired and supported by nature, which are cost-effective, simultaneously provide environmental, social and economic benefits, and help to build resilience. Such solutions bring more and more diverse nature and natural features and processes into cities, landscapes and seascapes through locally adapted, resource-efficient and systemic interventions. Nature-based solutions must benefit biodiversity and support the delivery of a range of quote-unquote ecosystem services. So that's the jargony definition that you get from the EU. Obviously there's a bit of leeway here between what counts as an afforestation project and what is a formal nature-based solution, but broadly speaking it's really just about restoring what was once there and an attempt to work with natural ecosystems where they exist much more closely to achieve what you want. So let's give some formal examples of ecosystems that are under threat, which could be protected or restored, and which would sequester that CO2 while providing additional benefits. And there are many, many examples here, and this episode would end up being extremely long if I tried to describe all of them in detail. So what I've chosen to do is to pick just one famous example, and really go in depth on that, and then understand that of course there are complexities and subtleties to each of the different nature-based solutions that one could hope to pursue, and lots of research that is ongoing into them and that has been going into them for many years. But we've picked one so that you can sort of get a representative example of some of the things we might be talking about. So this classic example is mangroves. These are essentially the shrubs and trees that often grow in salty water towards coastlines, especially in the tropics. They provide this natural buffer between the land and the sea, and that's where they flourish. And therefore they do several useful things for humans and human civilization as well as ecosystems that exist. So they help to reduce coastal flooding by absorbing the break of the waves that come in from the sea. But unfortunately this natural buffer has been increasingly under threat from deforestation in recent decades. For a long time these swampy ecosystems were just considered a bit of a mosquito-ridden nuisance by humans, and often they were simply cleared. In Myanmar, for example, 60% of the natural mangroves have been destroyed in just the last 20 years. They're often destroyed to make way for urban infrastructure, where the trees and shrubs will be cut down or pulled out, and then soil will be poured into there so that you can build houses on top of them. Or perhaps they'll be used for growing rice, oil palm and rubber. They'll be cut down for firewood sometimes, or to make way for shrimp or fish plantations. Or some of them simply die off under the weight of pollution in the nearby water ecosystems. Now, as well as playing host to some pretty unique ecosystems which can arise at the intersection of the forest and the ocean, the capacity that mangroves have to store carbon appears to be much greater than ordinary forests. This is the so-called blue carbon, which makes its way from these mangrove forests into the deep oceans via the coasts. And the reason why is pretty simple to see. We've talked already, and we will talk more in these episodes, about how you can get permanent carbon sequestration when biological matter falls into the ocean. When you have a nice mangrove forest, the organic matter that forms as they die and slide into the coastal waters forms a kind of peaty mulch, which locks up a good deal of the carbon, rather than just decaying on dry ground. And of course it also provides nutrients for other plants, algae, etc. to grow and thrive in this swampy ecosystem. It's one of these places that's really rich with different forms of life, and insect life and plant life and all this sort of thing. And the upshot in terms of the carbon cycle is that the organic carbon stored per square kilometre by these mangroves is substantially more than any other forest. Consequently, destroying them releases a great deal of CO2 and methane as they're allowed to decay. So in mangrove restoration, you have a classic nature-based solution. Done well, it would restore a natural ecosystem to the place it's supposed to be and was before human intervention. It would help to prevent coastal flooding, which of course is expected to get worse as sea levels rise with climate change. It's estimated, in fact, that the remaining mangroves provide approximately $57 billion in averted flooding damages in China, India, Mexico, the US and Vietnam every year. They can also provide an effective store of carbon long into the future, and they would have positive impacts for the biodiversity of the area. And when they're managed sustainably, they can also help to provide food and fishing stocks for the people who live there as well. All of this sounds so obviously win-win from this perspective that you may wonder why it's not underway already. But in mangroves we see the asymmetry that comes with wanton destruction. Ecosystems that take many years to build up and flourish can be destroyed in a matter of days or weeks, and the destruction tends to be substantially easier than any kind of serious restoration or repair. Attempting to actively reverse what we've done to the planet and these delicate and important ecosystems has a lot of related benefits, for obvious reasons, but that doesn't mean that it's going to be easy at all. For example, in many cases historically, attempts at mangrove restoration have been approached as if you're planting a forest on land. People grow lots of mangrove seedlings in greenhouses, and then they transplant them to these mudflats along the ocean's edge, and just sort of plant them and hope that you'll get a mangrove forest there. The problem is that this approach doesn't really work very well. In the Philippines, for instance, the World Bank spent $35 million to plant nearly 3 million mangrove seedlings in the central Visayas between 1984 and 1992. But by 1996, only a few years later, less than 20% of those mangroves had survived. This is for a number of reasons. For reasons of cost and simplicity, lots of attempts at restoration will just plant these monocultures again with a single species of mangrove that have been prepared. But you'll know by now that real forests are of course much more diverse than that, and that this diversity tends to add to their stability, allowing a greater number of species to flourish and survive in them, and allowing them to be resilient to different types of challenge. Planting in wetland ecosystems is more difficult than planting on land, because the seedlings can of course be washed away if they're planted incorrectly. Naturally, the mangroves will be submerged some of the time and exposed to the elements the rest of the time. If the balance is incorrect, the seedlings won't germinate properly, and restoration attempts will fail. Luckily, it seems that more detailed study of these ecosystems is starting to unveil some of these subtleties. And I should add that a lot of these subtleties were things that were known for a long time by the people who live there, and the people who lived with these ecosystems, and indigenous populations have known how to manage these things for a long time, but a lot of this knowledge has been lost in recent decades, and cast aside as these ecosystems have been destroyed. But Robin Lewis is a scientist who's worked on this for many years. Indeed, he said that he had to study mangroves in fieldwork for a decade before he even started to understand what was really going on with them. In the restoration projects that he's been involved in, the important thing is to replicate the hydrology for the forest, the way that the water sloshes around and meets the mangrove roots. The mangroves did their best when the roots were covered with water 30% of the time and dry the rest of the time. And actually this ratio turned out to be pretty important for getting a forest to work. So the large-scale restoration projects that Lewis and others have been involved in now take advantage of this. But to succeed, this means that you have to have quite a tailored niche approach for each forest that you want to restore. You have to do a large-scale hydrological survey of the basin. You have to gather data on how the water flows. Maybe you have to make a model that will tell you how the water will flow if you do certain interventions like digging trenches and so on. And doing that, you have to understand where the sweet spot for the mangrove planting will be. In many cases, you may need to alter the landscape, particularly if dirt has been used to fill in parts of the place where there was none before. You have to shift the dirt around, and they've done this quite often, to reproduce the appropriate sweet spot where the mangrove seedlings can flourish. And then, of course, you'll want to make sure that you have a nice array of different species to plant. In other words, as we've said, far easier to destroy an ecosystem and tear it up than it is to restore it properly. But it can be done. Actually, in this more holistic approach to restoration, you can often observe that as long as the hydrology is functioning properly, and there's an adequate supply of seedlings washing in, the mangroves will restore themselves over time, without too much active planting or management required to make it happen. This is all very good, but I do want to say, of course, that in thinking about nature-based solutions, just as in thinking about afforestation, we have to be careful not to fall too much into the naturalness fallacy. Just because it makes sense on many different levels to prioritise tasks like this, it doesn't mean that there aren't problems too, or that they don't have some of the same issues that pertain to other negative emissions. One of these, of course, is scale. Mangroves might be excellent at soaking up CO2, but they can only be planted across a very small region of the world where the coast meets the shore. One estimate suggested that in 2014, the carbon soaked up by the remaining mangroves was equivalent to around 0.4% of global CO2 emissions. For individual nations with high potential to restore mangroves, like Bangladesh, Colombia and Nigeria, a restoration programme could contribute a percentage point or two to cancelling out their emissions. But, just as in the case of afforestation more generally, doing something on a scale that has a significant impact on the vast scale of our carbon emissions is extremely difficult. And these scale problems and the uniformity of it, this obviously isn't something that we can actually neglect if we're going to lean on these nature-based solutions as a major plank in our efforts to mitigate climate change. I think there's an awful lot of potential to do good work here, and it's encouraging to see projects like Lewis's that are showing that this good work is starting to be done. But as will be increasingly clear, you can't just snap your fingers and expect nature to restore itself. And there are inertia in these systems too. Just as you need to train engineers and electricians to reduce carbon emissions by electrifying everything, so you're going to need the expertise and the experience to manage and restore these ecosystems, and that will have to be built up over many years as well. You have to divert resources to these projects, serious resources, to do things over a wide enough area. Just as you need to take time and take expertise and get people involved and get people engaged in your plans for a zero carbon electricity grid, so you will also need to create plans for a restorative approach to these natural ecosystems. So again, there's inertia here in how quickly these things can be scaled up and how we can build our capacity to do so. On the knowledge side, on the funding side, on the people you have to get involved and engaged, on the resources you have to mobilise, and of course, in the case of restoring ecosystems, you have to stop destroying them as well. And of course, with all of these approaches, there are concerns around carbon accountancy and greenwashing. The worst possible implementation here is that big companies, which are increasingly looking to get involved with this kind of project as good PR to show how climate conscious they are the ones driving this. Maybe they show up, they sponsor a relatively small pilot project for a few nature-based solutions, and perhaps a few 100 people, a small community is supported to restore a few hectares of mangroves. The company gets what they want, of course, lots of stories they can tell about how ethically and socially conscious they are, and maybe even a nice subsidy from a government to boot for a carbon credits trading scheme, which could be double counted towards targets. And meanwhile, the net impact of what you're doing is unclear. Maybe the deforestation just moves elsewhere, because you haven't approached the problem holistically or at a sufficient scale. In some ways, I can understand how frustrated and grim it must feel to be involved in this work, and how many of the people engaged in these efforts must feel frustrated, because it comes back to the last episode. Can we really talk about reforestation or restoring natural ecosystems when, in so many places, we're still destroying forests, destroying natural ecosystems, and apparently haven't figured out a way to coordinate society and production such that it doesn't need to destroy these things to continue making what we all demand? Indeed, we've talked in previous episodes about how difficult it is to design climate policies that really do what you want them to do. Unfortunately, in the real world, this stuff is not an apolitical activity that can be modelled hitch-free in our nice land agricultural type models. Listeners to the episode on bioenergy with carbon capture and storage, BECCS, will remember that we talked about how the biofuel mandate was imposed. 10% of all fuels have to be bioethanol. It's interesting, I saw a Republican senator tweeting about how happy he was that the UK has taken on this policy as well. I believe it was the same senator from South Dakota who was talking about how $15 an hour minimum wages was too much, even though, he said, back in my day I earned $8 an hour, and when they adjusted it for inflation it was $24 an hour that he had been earning. So it shows you that there are some interesting bedfellows made in climate policy sometimes. And, when we look at what the bioethanol mandate has done in terms of being a good substitute and a good subsidy for big agriculture in the US effectively, you can sort of see why someone like that might support it. In some ways, it's a classic neoliberal climate policy in the sense that what you do is you impose a mandate, which is not that neoliberal, but the aim of it is to get the free market to decide what the best solution is to provide that bioethanol. The argument is that the different people who can provide bioethanol will compete with each other, and through the magic of the free market, the best solution will be found, the cheapest and most effective solution will be found, and you will achieve your objective of reducing the amount of fossil fuels you use in cars. But free markets aren't free markets, as Ha-Joon Chang will tell you. They are maintained by laws and policies which are often shaped by the politics of governments, which means that they are often shaped by the participants in that market. A market, at any rate, is a form of allocating resources that's much closer to $1 one vote, rather than one person one vote. And in this particular case of the bioethanol mandate, we could see how it led to solutions that weren't all that great for the climate at large, with the mandate largely filled by corn to bioethanol conversion, resulting in a very small reduction in greenhouse gases and increases in food prices elsewhere. And of course, big subsidies and extra cash for the corn lobby, which was one of the existing participants in the market, which enjoyed leveraging its capacity to shape that market. You can similarly imagine that unless this is done carefully, introducing policies and incentives to encourage nature-based solutions for mitigation could have similar results. When you introduce these market-type incentives and carbon credits into an already existing structure, with corporations and big landowners who have their own incentives and influences over political power, you have to be really careful that you're actually going to achieve something that's going to do what you want it to and restore ecosystems and lock away carbon, and that you don't just end up giving subsidies to the already wealthy for schemes that fail in their objectives, cut corners, or are about maximising profits rather than carbon sequestration. Of course, part but not all of the problem really is the fact that regulators are weak and prostrate towards market forces, and so they're loath to introduce standards and laws, or in some cases they're not capable of monitoring or enforcing them properly because these things have atrophied over time as everything has been left to the market. That they can only actually introduce incentive carrots and let the market decide what to do, rather than introducing strict rules for carbon accountancy. And unfortunately we know that the market is a market, and therefore it will optimise for profits first, and whatever else you're trying to do as a secondary byproduct. Again, this doesn't mean that we can't hope to encourage nature-based solutions with carbon credits or anything like that, but you can't be naive to the realities of how these things often play out, and you have to make sure that your monitoring and accountancy of what's really being done in a given ecosystem is top-notch. And unfortunately that will add to the cost, although of course also the jobs that you'll need to actually make sure that you're restoring nature. Restoring nature will be a bigger job, I think, than destroying it. And it's remarkable to think of the amount of stuff we have to do, and the fact that we can still have unemployment in this context. But anyway, you have to be willing to regulate this stuff carefully and to be mindful of how many promises for reforestation and so on have ended up being broken or inadequately fulfilled in the past. And you have to make sure that you don't end up just selling green credentials or trading around carbon credits in a marketplace, while ultimately the net amount of CO2 that ends up in the atmosphere winds up being pretty much the same as it would have been if you had not done that. So again, we have a point here that it might actually be easier, paradoxically, to confirm that someone has sucked out and buried a ton of CO2 from the atmosphere if they've done so with a machine, although of course you won't get any of the co-benefits from restoring the ecosystem. Say it with me now, it's complicated. Secondarily, of course, there are the equity issues associated with this. There are reasons that the mangroves are being destroyed and can't be restored easily at the moment. The question of who will pay for the restoration, and who's at best going to ensure that all of the would-be shrimp farmers or builders on the mangroves are able to find another source of income, is a fraught one that we have not determined yet through our international political processes. Again, most of the potential for pursuing these nature-based solutions is in poorer nations in the tropics who are disproportionately affected by climate change and have also disproportionately not contributed to the problem. So any climate change plan that has to focus on these nature-based solutions is going to have to take these equity and justice dimensions into account, so that it doesn't just become another burden-shifting exercise from rich to poor nations, or even from urban to rural populations within a nation. But at present, unfortunately, all of the perverse and bad incentives which encourage people to destroy these ecosystems for profit or simply for survival are still firmly in place. And yeah, sorry to keep going on about this, but it's a serious problem with lots of these strategies, no matter how you try to frame them. The research that has been done, of course, does back this up. There was a study on mangrove restoration specifically in Vietnam, which found that failure in mangrove programs can be attributed to lack of understanding of the reasons for the loss of mangroves, poor site and species selection, and the lack of incentives to engage local residents in the long-term management of these restored areas. So there's a fear that you can come along with your big shiny restoration project, and then once that's over and you've broken the ground on it, well, the same problems that have been occurring with the natural ecosystems just come back again. In other words, as should be obvious to everyone by now, this isn't something that you can just impose on people and hope it will be a sustainable solution. If the incentives are still there to destroy the mangroves, you haven't solved the problem. And it's all very well for wealthy Westerners who no longer need to live off the land and have already destroyed most of their ecosystems, to simply decry the ignorance or short-termism of people who are destroying mangroves, or try to impose bans or sanctions on such activities. But there's a glass houses and stones problem, before you even get into the role that multinationals play in deforestation. Quoting from Monga Bay, here's an example of a project that took a more holistic approach. Quote, Mikoko Pamjoa, or Mangroves Together, is a community-led restoration project along Gazi Bay on Kenya's south coast. Established in 2014, it's one of the world's longest-running such projects, and has now become the first to use mangrove carbon credits to protect its blue forests. Mohammed Bamani, the treasurer of this project, says that fishing is crucial to everyone who lives around the bay, and that seafood is their only source of protein. Mangrove forests provide the best environment for fish breeding, he says. In 2014, deforestation spiked along Gazi Bay, and the mangrove lost around 2% of its tree colour, according to satellite data from the University of Maryland. Bamani says he and his colleagues began the restoration project because they realised that they were the only ones who could save the mangroves. People were quick to buy into the project, Bamani says, which has created more than 150 jobs. An influx of money from carbon credits managed by the international carbon credit regulator Plan Vivo has helped the community make changes in some important areas of their daily life, he says. These include improvements to the local water supply, the renovation of primary schools, and the stocking of the local medical dispensary. Around 2.5 million trees are protected through Mikoko Pamjoa, along with a second programme it inspired called Vanga Blue Forest. The project's secretary, Harith Suleiman, says that the climate change is causing more extreme weather events, and not having the protection of the mangroves meant that the village was at constant risk of flooding. Like many villagers, Suleiman comes from a fishing family, inheriting his knowledge of where to fish and his respect for the mangroves from his ancestors. The mangrove contributes to the ecosystem balance, he says. Where there is mangrove, there is seagrass, there is coral, and a diversity of marine life. But he says that people have overexploited the resource and cut down large areas to build houses. To combat this, they are encouraging more young people to join in the restoration work. To date, Suleiman says, more than 750,000 seedlings have been planted. This is their resource, he says. Nobody from outside will come and protect this, they are the ones who must do it. Satellite imagery from Planet Labs shows mangrove cover has expanded in the past several years. End quote. So it would be so lovely to see much more of this type of project going on, and you hope that this sort of thing can be replicated at a much bigger scale across many of these protected areas, and not just in a few individual pilot projects. It might sound a little wishy-washy and hard to define to say that it's as much about changing our approach to nature as anything else, but I think that there is a grain of truth to that. And there's an interesting contradiction there between the idea of restoring ecosystems, but doing so because we realise we value the services they can provide more to us than if we destroy them, if we restore them, than if we destroy them. That's probably a whole philosophical debate about the commodification of nature that we can leave for another day. I've chosen the mangroves as this example of a specific ecosystem restoration to go in depth on, in part because they're a famous and classic example, and have many of the advantages and co-benefits that you have, as well as the problems that you can run into when you're trying to do these nature-based solutions and ecosystem restorations. But these issues and concerns and the subtleties involved in restoring what we've easily destroyed are common across a number of different solutions we can describe. That's why I chose to go in-depth on this one approach rather than just listing sets of different ecosystems that we can seek to restore, although of course we could have many episodes on this. I don't want to get into too much depth. Although, of course, we could have many episodes on this, but I don't want to get into too much depth on areas that I'm less confident in. Of course, these nature-based solutions are a whole field of study in themselves, but I will briefly talk about some of the other ecosystems as examples that are considered under this rather jargony label before we sum up. Peatlands are another great example of this. We talked about them in the drawdown episodes. They're more ecosystems with this sort of carbon-rich mulch in them, which comes from partially decaying vegetation, a bit like what you have in the mangroves. Conserving and restoring these peatlands is a no-brainer for the climate. In many countries, peatlands have been artificially drained over centuries, leading to enormous emissions of CO2. It's estimated that in the EU, these drained peatlands may emit as much as 220 million tonnes of CO2 equivalent, in the form of methane and other greenhouse gases, as well as CO2, which is equivalent to 5% of the EU's total emissions. And, that's on a par with some things like aviation and so on. It can't be that much smaller than aviation. And these figures may be reflected globally as well. A disproportionate fraction of the greenhouse gas emissions associated with agriculture are also down to agriculture that is taking place on peatlands that have been converted for that purpose. Of course, destroying the peatlands has other negative impacts on the surrounding area too. You get soil subsidence, you get mobilisation of nutrients away from the places, you get higher flood risks and loss of biodiversity from these ecosystems. The good news is that you can largely solve some of these problems by stopping the drainage and allowing the land to become wet and peaty once more. These wet peatlands do not release CO2, they can potentially sequester carbon on average. They help to improve the water quality in the local area, and they provide habitats for these rare and threatened biodiverse species of animals and plants. And if they're used sustainably as well, you can still get biomass out of them for burning and so on, which is one thing that a lot of peat has been used for in the past. That's called paludiculture. So I learned a new word in researching this. Wisely adjusted land use on peatlands can substantially contribute to these low emission goals, and it can further benefits for the farmers who use the peatlands and, society, the environment more broadly. There are some other nature-based solutions to talk about. Forestry practices that come under the category of nature-based solutions include allowing forests to regrow naturally where they've been cut down, and improving the management of existing forests, preventing wildfires and other sources of emissions. We've talked about wetlands more broadly as a category of landscape, but they include peatlands and mangroves. There are other wetlands too that you'd want to preserve. We've discussed in previous episodes, including quite a bit in the Drawdown series, ideas about regenerative and restorative agriculture, practices that build up the carbon in soils, such as agriculture with no tilling, or covering the crop rotation, agroforestry, changes to how livestock is managed, all that sort of things. In urban landscapes, you still have options, rooftop gardens, urban trees, that kind of thing. They can have impacts on flooding and drainage, and urban heat islands they can help to reduce as well, while storing a little bit of extra carbon. So again, you can see that some of these nature-based solutions are kind of on the borderline between adaptation and mitigation. So they both help you deal with some of the impacts of climate change, as well as helping you to reduce CO2 in the atmosphere. There are some ocean-based practices as well, these ocean ecosystems which we know have been affected by humans even though we don't go there that often. Ocean-based practices include restoring seagrass meadows, growing kelp or shellfish to restore or expand these marine ecosystems. On the climate adaptation side, coral reefs and oyster reefs often provide the first line of defence against flooding and tropical storms for many different regions across the world. so protecting what remains of them and restoring them where possible will have benefits for helping humanity to adapt to climate change. Returning areas that were once floodplains to floodplains again, rather than trying to build urban infrastructure on them, and other forms of rewilding. These are examples of nature-based solutions that straddle the borderline again between adaptation and mitigation. And you will even hear some people talk about things like protecting and expanding whale populations, because whales, during their lifetimes, eat a lot of plankton, they eat a lot of krill, they accumulate carbon in their bodies, which then sinks to the ocean floor when they die, and can end up being permanently buried there. There was an interesting paper recently which tried to estimate this pump of carbon to the deep ocean that came from these whales, and suggested that, if you had as many whales as we used to, there could be millions of tons of carbon that were actually ending up at the deep ocean if we were able to restore whale populations. That's an interesting paper. I don't know if people are going to come along and criticise it, but it's just a point that there are many natural ecosystems that we've destroyed, which have been part of the process that has allowed the land-based carbon sink in many places to become a carbon source, and reversing these would return things to pre-industrial conditions in ways that would be good, I think, for the climate. So as you can probably figure out, it would be possible for me to devote many episodes to the litany of nature-based solutions that are being suggested and explored. That would make the series longer than it already is, and I've done a lot on negative emissions, so I want to close with a few points. On the whole, it seems obvious to me that if negative emissions are the last thing that we should be thinking about when it comes to climate change, then nature-based solutions are the first type of negative emissions that we should be thinking about. Many of these approaches to restoring ecosystems are obviously the right thing to do for the environment and for the climate more broadly, reversing at least some of the destruction that humanity has wrought on various different places. And frankly, the reason that we have done all of this destruction is because these ecosystems and this environment that we have converted into capital and material resources, these things have done useful services for humanity. That's why we have exploited them so much. There are ecosystems out there that can provide food and fresh water, carbon sequestration, areas of outstanding natural beauty, biodiversity, services to human populations like flood defences. These ecosystems are the things we need to restore, and doing so just sweetens the deal for doing this in general, beyond just a carbon accountancy solution. So, considered as something that we should do to protect, preserve and restore, it's clearly something that needs to be focused on and actually acted upon beyond just words and commitments. It would be wonderful to see all of this happen, and even though many climate benefits might be hard to estimate or know for sure, they could be substantial. With all of that said, though, we have to bear in mind that many of the same problems with negative emissions don't go away just because we're attempting to do it now in a natural way. For a start, of course, it seems crazy to talk about restoring ecosystems when we're all still engaged in destroying them at an incredible rate. If we can't learn to manage what we have sustainably, then restoration is running uphill. It's just an activity to make us feel better about ourselves, really. All of the same concerns about shifting the burden of climate change onto future generations, or onto other populations than the ones who are responsible, who are required to engage in ever more restoration of the natural world, they also exist here. So do all of our concerns that we are making promises that can't be kept, or relying on global ecosystem restoration that may not materialise, and that's changing our approach to climate change because we believe these things can be possible. Just because it's a green solution and not envisioning dozens of factories that will suck CO2 out of the air doesn't mean that it doesn't have these same impacts on the way we talk about things, on the way that policymakers deal with it, on the scenarios that we imagine. And is it that much more realistic to suggest we can restore all of these ecosystems in the next 20, 30 years than it would be to do other things, to do different types of technical solution? I don't know. Well-intentioned people certainly want to believe that nature-based solutions will solve our climate change problems and environmental problems together. And perhaps this can cause them to slightly exaggerate the capacity of nature to heal itself, if only we allow it. But we cannot delude ourselves about the scale of the damage or the scale of the carbon that we've emitted. We dug it up. Hornigold's law still applies. You have to do this at a massive scale to make a reasonable impact on the climate, and that won't be easy. Even the most optimistic estimates for many of these nature-based solutions still won't add up to enough CO2 reduction for the Paris Agreement goals, unless we also slash near-term emissions dramatically. So again, this is an as-well thing rather than an instead-of thing. And that would be assuming quite high levels of ecosystem restoration across the world. When we talked about the mangroves, hearing about these projects is wonderful, but the idea that their potential at most would be to contribute a percentage point or two to certain countries where they can be restored in their carbon budgets, that gives you an example of this. It doesn't mean it's not worth doing or that it's not worth giving the highest priority to these things, but it is a reality check on what they can achieve. Doing this correctly is complicated. It often requires a lot of specific knowledge about the ecosystem you're attempting to restore, as in the mangroves case. There's no one-size-fits-all approach that's going to easily scale up and be replicated across the world. Instead, you have to have a degree of tailoring it to individual situations. That's going to depend on factors like the existing ecosystem, the existing communities, the existing politics, and so on. Otherwise, the chance of failure is high. And this is me having not done that much research on anything other than mangroves here, but you can just see the number of things that you're going to need to take into account to actually get this to succeed. From a project management point of view, if anyone has ever tried to do something complicated, if you look at how our attempts to even just build things that are fairly standard often overrun and run into problems that no one could have imagined, you need creative thinking and time, resources, patience to do these things. Of course you do. These solutions then, they're going to take time and money to develop, and that means there will be an equity and justice dimension to it, especially when it comes for who's paying for the equities and activities to take place, and who has to stop what they're doing right now in exploiting these ecosystems, and how everyone will be compensated. As with other negative emissions with complex life cycles associated with them, there need to be rigorous standards of accounting and accountability to make sure that you're actually drawing down the CO2 that you intend to, or say that you do on the certificate. And as other solutions have found in the past, it's perfectly possible that imposing market incentives on an already perverse market results in outcomes that are the opposite to what you want. So for nature-based solutions, there are two worlds, really. In one, the buzzword remains a buzzword. We get lots of lofty promises and lots of white papers, and then a few hasty projects are undertaken in a haphazard fashion by national governments or NGOs, and then they get abandoned or reversed over time or don't succeed as intended. They get used as greenwashing and PR for corporations, or as a means of doing some dodgy carbon accounting to claim that an activity is clean and net zero, when in actuality the impacts are more uncertain. And they're undermined by insecure, cost-cutting, industrialised approaches that leave out the communities who are actually going to have to interact with these ecosystems and the landscapes in the long term. And in that world, nature-based solutions, nice idea, never really lived up to the potential. And then there's the other world, in which our implementation of this stuff actually does what it intends to. And it starts the process, I think the necessary process, of healing the earth from the damage that our initial spurt of civilization and humanity and industrial civilization has done, returns these ecosystems to their former glory and natural beauty, renders us and our climate healthier in the long run, and is a part of what we need to do, which is rebuilding the foundation of everything that we have now, of all of the lives that we can live now, of all of the futures that we can imagine now, on a footing that genuinely is sustainable, on a footing where we're genuinely not undermining the planet that we live on, because we're not going to find another one, we're not going to move to Mars. This is what we've got. And our choice is going to be to get to the end of the century or get to the middle of the century, starting to get on the right track with this and starting to really live in a way that is sustainable and that can be sustained and that doesn't require such relentless destruction of the natural world, or we are going to find that we're not as smart as we think we are. And that is a really important task that we have to start. But it will require us to get serious and devote some serious time, intellectual and financial resources to actually, restoring nature. So which of these two realities we end up in is, of course, still up to us. As the late, great anthropologist David Graeber said, The ultimate hidden truth of the world is that it is something we make and could just as easily make differently. Thank you for listening to this episode of Physical Attraction, where we've been talking about nature-based solutions. You can find us on the web at physicspodcast.com. There you'll find the contact form. If you have any comments, questions, or concerns, please get in touch through them. I always love hearing from listeners. I try and respond to the things that you say. I'll respond to them in emails, and I'll respond to them by changing the show and hopefully making it better, because I'm determined to make this better every single time you listen to it. Fingers crossed. We're starting to succeed in that. You will also find there the episode guide. We have over 200 episodes now, and they are on topics ranging from the meaning of life to the history of nuclear fusion, through to the birth of stars, science in the Soviet Union, Huey Long. There's a big range of different topics that you can hear me witter on about. If you want to go to the episode guide, you'll find out some of those. And amazingly, some of these things, it's not just me who's wittering. You can listen to the interviews that we've had with scientists, scholars, friends, economists, all through the years. So many interesting people who are much better to listen to than me, who you can find as part of the episode guide. And that is a good place to send your friends. If you think they would enjoy this show, if there are some topics you'd like them to listen to, please do recommend that they go there, head there, see what's on offer as part of our archive. I would really appreciate that. There are other ways to get in touch with us, of course. You can find us on Twitter at PhysicsPod. You can find the subreddit, Physics Podcast, remember to plug that this time. And you can find the Science Podcasts group on Facebook. All of those are worth your time, I hope. There are other ways, of course, you can support the show, which you will find on the website physicspodcast.com. You will find the Patreon there. If you're listening to this early, then you will have listened to it through the Patreon, so I thank you for your subscription and your support of the show. If not, what are you doing? Go over there, subscribe to the Patreon. Normal amount of money. You can get loads of bonus episodes that aren't available anywhere else, and you will get every episode, often months in advance. When I'm recording this now, there's about 20 episodes, I think, that you can get early on the Patreon, so it really is an extra load of resources. If, for some reason, you have not got sick of the sound of my voice. Until next time then, please do, take care.